Okay, I'm going to show you how to make a circle graph. It's really fun and it's pretty cool, and it involves some proportions, some math, which used to be a 7th grade math skill. I don't know if it's still 7th grade, but first of all, we want to find the center of our circle. So what I'm going to do, and I don't know if this is going to show up on video, but I'm going to fold this over and I can see through the paper, and actually I got to put it in front of me a little bit more, sorry. Oh, I got to put it right in front of me. Oh no, I can't see it on this blue paper. Okay, well, on the white paper, let's see if I can do it like this. You can see when the lines are lined up, it'll shows up through it. And then I can kind of tiny see, you can see, there we go. If I get a little light behind it, you can see when the lines are lined up this way. And again, this is hard to show on video and it's hard to use words for. It's easier to show. So if you can't see what I'm doing, no worries, I can show you when you're back. But what I have now is I've got a center point, and I'm actually going to make a line here, and that's going to be my starting point for my first slice of the pie, if you will. And let's see here. So 42%, 25, so this is sources of energy in the United States. The energy types are petroleum, coal, hydroelectric, natural gas, and nuclear. And these are our percentages, how much of the pie they take up. So I've done all the math here. I'm not going to do all the math, but 4% is about 14 degrees. 9% is about 32 degrees. Let me show you how I'm doing this. So 42%, let me make sure it's in the video. 42% equals 42 out of 100, right? So I'm going to set up a proportion. So if the part is 42 and the whole is 100, well, how many degrees are in a circle? A circle is 360 degrees all the way around. So the whole is going to be 360, and I want to know how many degrees would represent 42% of a circle. And teachers teach us a lot of ways how to solve this. There's cross multiply and divide, there's the butterfly method, the C method. But basically, I'm going to cross multiply. So I'm going to do x times 100 is 100x equals 42 times 360. And I did not get my calculator ready, but I should have it quickly. I think it's like 15,000. Yeah, it's 15,120. And then I want to solve for x using a one-step equation, which is divide by 100, divide by 100. This becomes 1x, or just x, and this is 151.20. So what that means is that 151 degrees is equal to 42% of a circle. Okay, so petroleum, I'm going to need 151 degrees. I already know that 1/4 of a circle is 90 degrees. So a whole circle is 360. A straight line, if I continue this over here, is 180. And this, a quarter of a circle, is 90 degrees, not percent, degrees. So let me erase these lines. And I'm unclear how much of that you've learned in math. A, because I don't remember what part that is, what grade that is in math anymore, because I've been teaching science for a while. And because of the pandemic, so just remember, a circle is 360 degrees. Half of a circle, also known as a straight line, is 180, and a quarter of a circle is 90 degrees. So I'm going to do that one, but let me do 20 degrees, or 20%. Okay, so natural gas, I want to know how many degrees represents 20% of a circle. So 20 out of 100 is equal to an unknown amount of degrees out of 360, and this is called a proportion. So I'm going to cross multiply, and I'm going to get 100x is equal to, I believe, because I've done this a few times today already, it's 7,200. And then I divide by 100, that's 360 times 20 is 7,200. I divide both sides by 100 to solve for x. To get x alone, I get x equals 72. So that means that 72 degrees equals 20% of a circle. Can you see all that in your frame? Yep. Okay. So this is going to be 72 degrees. Now that we have found how many degrees we want each slice to be, I am going to make my first slice. Actually, let's do the 90-degree slice first, because why don't we just make it this quarter? We know that 90 degrees is 25%, or a quarter. And when I folded my circle, I got a nice quarter. So that is going to be coal, 90, I keep mixing up my degrees and my percent, 25%. Good thing I am making my graph in pencil. Remember, we can erase pencil. Mistakes are good. We just need to be able to erase them. Okay, so now I'm going to take my protractor. I'm using my protractor to measure degrees and also as a straight edge. I've been using it as a straight edge, but now I'm going to use it to measure degrees. And let me see if you can see this, I have this little crosshairs here on my dot, on my center point, and this little black line, the start of the degrees, 0 degrees, is lined up on my pencil line. Can you guys see that? And now I'm going to go around, so here's 0, 10, 20, 30, 40, 50, 60, 70, and remember we're going to 151. We're going to 151 degrees for petroleum. 80, 90, 100, 110, 120, 130, 140, 150, and then it's a little hard to be accurate here, but we're going to do our best to be a little bit above 50, and then we're going to draw a line from our center point to that point, and then I'm going to erase the outside. That is 42% of the circle. It's 151.2 degrees, but we can go ahead and go with 151. And this slice is petroleum and 42%. Okay, so we've done this one, we've done this one. And you can, I'm not going to pause here because you guys can pause the video. So let's do, I want to do 72 next, 20% of the circle. 72 degrees or 20% of the circle. And I want it to be 72 degrees from here to my next line. So I'm going to turn my paper because this line needs to be my 0 line. And I'm going to take the crosshairs and I'm going to line it up on the 0 on the center point and get my black 0 line lined up on my pencil line. And then I'm going to go up to 70 and try and get a mark at about 72. Okay. And then I'm going to use my protractor as a straight edge. And I'm going to go ahead and just stop my line at the edge of the circle. And so this is natural gas. And 20%. I almost wrote 72. I almost wrote 72 degrees again, but I wrote 20%. Okay, natural gas 20%, which is 72 degrees. So we did that one. So we have two left, 14 and 32. So let's go. I'm going to turn my paper again. I'm going to do nuclear, which is 9% of the sources of energy in the United States, according to this data. I don't know that that's actually accurate data. 9% or 32 degrees. So I'm going to turn it again because I want this line to be my 0. And I'm going to put my crosshairs on my center point and my 0 lined up. And I'm going to go out to about 32 degrees as best I can. And I'm going to make my line, and I'm going to stop here. And I'm going to label. This is nuclear. And this is 9%. So that leaves this slice, which should be approximately 14 degrees. Let's take a look. 14 degrees or 4%. Yeah, it's a little off. If I move my hand, it looks a little more like 16 to me, 15 or 16. And that's okay. This protractor is not terribly precise, but this is pretty darn good for having a small protractor that's not terribly precise. So I'm going to go ahead and put 4% here, and I'm going to write hydro. That looks like a G, not a Y. Hydroelectric. And so I've done this one and I've done this one. And that is how you make a pretty accurate, decently accurate circle graph for real without just estimating. We did a little estimating because our materials were not terribly precise, but this is pretty darn accurate. So again, we have petroleum is a 42% slice, which is about 151 degrees. Coal, a 25% slice, which is 90 degrees exactly. Hydroelectric, which is 4% of the circle graph, which is about 14 degrees. Natural gas, which is 20% of the circle, which is exactly 72 degrees. And nuclear, which is 9% of the circle, or about 32 degrees. If you were to add these up, you would get 359 degrees. Because it was hard enough to, for example, get 151 accurately, let alone 151.2. So we didn't even attempt the decimals. Okay? But remember, a circle is 360 degrees all the way around. Half of it is 180, and a quarter of it is 90. Thank you for watching. If you can make this at home, that's great. If not, we can make it together at school. Have a great day, and bye.